In late 2017, astronomers made an extraordinary discovery that shook the scientific community and ignited discussions around the world. The object, named Oumuamua, meaning scout or messenger in Hawaiian, was the first ever interstellar object observed passing through our solar system. Unlike anything seen before, it captured attention not only because of its origins outside our solar system, but also due to its unusual shape, behavior, and trajectory. This led to a series of scientific inquiries, with some experts even considering the possibility that Oumuamua could be an extraterrestrial spacecraft or probe sent by an alien civilization. The detection of Oumuamua was a breakthrough in astronomical history. Up until that point, all known celestial objects like asteroids and comets had originated from within our solar system. The idea of objects traveling between star systems had long been theorized, but Oumuamua was the first piece of direct evidence that such interstellar travelers exist. It was first spotted by astronomer Robert Warwick using the Pan-STARRS 1 telescope in Hawaii on October 19, 2017, and initially thought to be a comet or asteroid. However, it quickly became clear that Oumuamua was no ordinary object. One of the most striking features of Oumuamua was its highly unusual shape. Early observations suggested that the object was elongated, roughly 10 times longer than it was wide, resembling a cigar or pancake-like structure, which is not a typical shape for comets or asteroids. Most celestial bodies are more rounded due to the effects of gravity, but Oumuamua's dimensions defied these expectations. This peculiar shape, combined with its tumbling motion through space, led to various hypotheses about its origin and structure. Was it a fragment of a larger object, or could it be an artificial structure sent from an alien civilization? Adding to the mystery, Oumuamua exhibited non-gravitational acceleration as it passed through the inner solar system. Typically, comets accelerate due to jets of gas and dust being expelled from their surfaces when they are heated by the sun, creating a visible tail. However, Oumuamua showed no such tail, and yet it sped up as it moved away from the sun. This acceleration without an apparent cause sparked much debate. Some scientists proposed that it could be due to the sublimation of hydrogen or nitrogen ice, while others offered more exotic possibilities, including the idea that it could be propelled by some form of advanced alien technology. The most notable proponent of the alien spacecraft theory was Harvard astrophysicist Avi Loeb. Loeb suggested that Oumuamua's unusual shape, lack of visible outgassing, and unexplained acceleration could be explained if it were an artificial object, perhaps a light sail. A light sail is a theoretical form of spacecraft propulsion that uses the pressure of photons from a star to propel an object forward, much like a sailboat uses wind. Loeb's suggestion that Oumuamua could be a relic of alien technology, perhaps a probe sent to observe our solar system, caused a sensation and was met with both intrigue and skepticism. Most astronomers, however, have leaned toward more natural explanations. Some theories suggested that Oumuamua could be a fragment of a planet or a moon from another solar system, ejected during a violent event such as a collision or the gravitational pull of a gas giant. One idea put forward by researchers Alan Jackson and Stephen Desch proposed that Oumuamua might be composed of frozen nitrogen, similar to the surface of Pluto. They theorized that it could have been chipped off a Pluto-like planet in another star system during a massive impact and then sent hurtling through space. This would explain its acceleration, as nitrogen ice could sublimate under the heat of the sun without producing the visible tail usually associated with comets. Another theory, proposed by Daryl Seligman and Jennifer Bergner, suggested that the object might have been made of hydrogen ice. In this scenario, hydrogen gas trapped in the ice could have been released as Oumuamua was warmed by the sun, providing the observed boost in speed without leaving a detectable tail. This model also fits with the fact that Oumuamua was unusually shiny for a celestial object, reflecting more light than expected, which might be explained by its icy composition. Despite the various hypotheses, there is still no definitive answer to the mystery of Oumuamua. Its brief visit through our solar system was fleeting, and by the time it was discovered, it was already on its way out, making it impossible to study up close. Since it passed through so quickly, the window for detailed observations was limited, and by early 2018 it was too far away for even the most powerful telescopes to get a good look at it. Oumuamua is now traveling beyond the orbit of Neptune, headed toward the constellation Pegasus, and it will soon be lost to us forever. The detection of Oumuamua has sparked a renewed interest in the search for interstellar objects. In 2019, a second interstellar object, named 2I/Borisov, was discovered. Unlike Oumuamua, Borisov was much more comet-like, with a clear tail and typical behavior for a comet. This has led scientists to believe that interstellar visitors may be more common than previously thought, and future discoveries could provide more clues about the nature of objects like Oumuamua. Although most experts believe that Oumuamua was a natural object, its strange characteristics have forced us to confront the limits of our understanding of the universe. It has also reignited the scientific community's interest in the possibility of extraterrestrial life. The idea that Oumuamua could be an alien probe is exciting because it pushes the boundaries of what we consider possible. Even if it turns out that Oumuamua is just a peculiar natural object, its visit has broadened our understanding of how diverse and unpredictable the cosmos can be. In the years since Oumuamua's discovery, efforts to prepare for future encounters with interstellar objects have ramped up. Astronomers are now better equipped to detect and track such objects more quickly, and projects like Breakthrough Starshot are exploring the possibility of sending small, fast-moving probes to study them up close. While it's unlikely that we will ever catch up to Oumuamua itself, the lessons learned from its brief visit could help us be ready when the next mysterious object comes our way. The mystery of Oumuamua has captivated scientists, astronomers, and curious minds around the world, leaving us awestruck by its strange characteristics and igniting a wave of excitement and speculation about what lies beyond our solar system. Its unexpected arrival in 2017 marked a moment of profound intrigue, as Oumuamua was the first known object to enter our solar system from interstellar space. In a universe filled with mysteries, this alien visitor, unlike anything we had ever observed before, challenged our understanding of the cosmos and opened the door to a new realm of possibilities. From the very beginning, Oumuamua defied expectations. Initially, astronomers thought it was just another comet or asteroid, a type of object that we are familiar with. But as they observed it more closely, it quickly became apparent that Oumuamua was unlike any known comet or asteroid. Its elongated, cigar-like shape, estimated to be up to 10 times longer than its width, was unprecedented. Most objects in space are roughly spherical or irregularly shaped, but Oumuamua's dimensions and its strange tumbling motion made it unique. Even more puzzling was the fact that it didn't display the typical behavior of a comet. There was no visible tail, no cloud of gas or dust, and no signs of the usual outgassing that occurs when a comet approaches the sun and heats up. This left scientists questioning what exactly they were looking at. One of the most intriguing aspects of Oumuamua's journey was its speed and trajectory. It was traveling far too fast for it to be gravitationally bound to the sun, meaning it wasn't part of our solar system. Its hyperbolic trajectory indicated that it came from somewhere far beyond our planetary neighborhood and was just passing through, never to return. This realization added to the growing sense of mystery. Where had it come from? What forces had ejected it from its home system and sent it hurtling through interstellar space? And what were the odds that we just happened to detect it as it made its brief passage through our solar system? As astronomers continued to study Oumuamua, they found another anomaly. It was accelerating in a way that couldn't be fully explained by gravitational forces alone. Usually, comets accelerate due to outgassing, where the heat from the sun causes ice on the comet to vaporize, creating a jet-like force. However, no such activity was detected with Oumuamua. This unexplained acceleration led some scientists to propose more exotic hypotheses, including the idea that Oumuamua might not be a natural object at all, but rather an artificial one, perhaps a probe or a spacecraft sent by an advanced extraterrestrial civilization. This theory was most prominently suggested by Harvard astrophysicist Avi Loeb, who argued that the peculiarities of Oumuamua's shape, its unusual movement, and its lack of comet-like behavior might point to an artificial origin. Loeb speculated that it could be a light sail, a type of spacecraft propelled by radiation pressure from stars. Light sails are a theoretical technology being explored on Earth as a potential method for interstellar travel, and the idea that an alien civilization might have developed such technology is not entirely far-fetched. Loeb's hypothesis sparked a debate in the scientific community, with some supporting the idea of keeping an open mind and others dismissing the notion as too speculative. Regardless, it added another layer of intrigue to the already fascinating story of Oumuamua. While the idea of Oumuamua being an alien probe is exciting, most scientists still lean toward more natural explanations. One of the leading theories is that it could be a fragment of a larger object, possibly a shard of ice or rock that was ejected from its parent system through some kind of violent event, such as a collision or gravitational interaction with a massive planet. Some researchers suggest that Oumuamua could be made of a material like nitrogen ice, which would explain its reflectivity and unusual shape, as well as its lack of a visible tail. Another theory posits that it could be a fragment of a Pluto-like planet from a distant star system, sent on its way millions of years ago.